Hello Year 9, I hope you've had a really good couple of weeks. Maybe you've been able to see some more of your family. I can't remember if last time I spoke to you, you were allowed to see 6 people or not, but maybe you can, maybe you've been able to see grandparents, whatever. Hopefully you have, and hopefully you got on okay with all that work about speed. And I've submitted that to your teacher on Teams because if you're watching this on the 22nd, it will be due today. And this piece of work will be due on the 6th of July. So remember, on the first week, so this week, you just need to go through the PowerPoint, make sure you've done any notes, and make sure you ask your teacher any questions that you've got. And then the following week, so the second week of this assignment, is when you do the work and do the questions on the Word document and then submit that to Teams so that your teacher can give you some feedback. As always, there's some links at the bottom of here, so you can click on that in the PowerPoint version. And I think I'll try and put those in the actual assignment thing for you as well, so that you've got them to click on Teams. I'll try and make sure I do that. Okay, so let's get on with some acceleration. Okay, so you'll need some line paper or something to make some notes on just for this first bit, or you could type it if you want to, it's completely up to you. So there's some questions in the yellow box, and at the bottom there's a graph, and this is a distance time graph, and you should have seen one of these before. So we've got distance on the y-axis, time on the x-axis, and it's just showing you 4 different journeys of different people. So have a go at these questions in the yellow box. Which person is moving the fastest, who's moving the slowest, calculate their speed, and whose motion has changed. So as in during the journey, who changed their motion. So I'll give you a little clue. The steeper the line, the faster the motion. And the less steep, the slower. There's a little typo there as well. Sorry, that's supposed to say fastest. Okay, so pause the video now and have a go at that, and then we'll come back to the answers. Okay, so hopefully you've had a go at that. Question 1, who was moving the fastest? So the steepest line, the fastest person is definitely, oh, can't see yellow, can we? First one is definitely going to be Ivan. Sorry guys, I'm having a problem with my pen. Yeah, so number 1's going to be Ivan because that's the steepest line. So he's covering the most distance in the least time. So he's definitely going fastest. So likewise, the person that's going to be going slowest is going to be Joy. And we're looking at the first 10 seconds, remember. So we're only looking at that part of the graph for this. There. Calculate Chris's speed for the first 10 seconds. So I can see that Chris goes 100 meters in 10 seconds. So 100 divided by 10 equals 10 meters per second. And calculate Joy's speed. Number 4, the first 10 seconds. Joy goes in the first 10. I'd read that as 50. Hopefully you agree with me. 50 divided by 10 equals 5 meters per second. And number 5, the person whose motion changed. So if the line on one type of graph like this is a straight line, that means that their motion doesn't change. It's just continuous motion and they're moving at a constant speed. But if you look at Shirley, she travels 60 meters in the first 10 seconds and then she doesn't travel any further. She just stops at 60 meters. She didn't go as far as the rest of them. So the last answer is Shirley. Hopefully you can read that. All right, hopefully you got those right. Brilliant if you did. Okay, so still on your page, you need to copy that diagram, the diagram of Silverstone. It doesn't have to be perfect copy at all, just kind of like that shape, because we're going to try and annotate it together. So what I want you to do is to annotate your diagram with when you would use the words accelerate, decelerate and constant velocity. So if you think of a car going around that track, at what points would they be accelerating? When would they be decelerating? That means slowing down. And when would they be going at a constant speed? So try and highlight a couple of points for each one, and we'll have a go at doing that together in a minute. So pause it now and have a go at that. hopefully you had a go at it. So I'm going to color code this so that we can do this together. So I'm going to use red for accelerate. So points where it's accelerating. He's definitely going to be accelerating. I don't know why it's man, sorry. They can be, anyone can drive a race car. They'd probably be speeding up here. Also, when you come out from round a corner, you'd be accelerating there, wouldn't you? Like this point here, because you have to slow down to go around a corner and then speed up again. And also like here, I've done 3 there. If I'm thinking of deceleration, I'll use a different colour. I'll use green for that. So slowing down before you go around a corner, you need to slow down. If you go around a corner too fast, then you'd lose control on the bend, wouldn't you? Other times of slowing down, another one here. Oh, can't do that. There we go. Maybe here, because it's quite a wiggly point on the track. And finally, constant speed, I'll use a C. So any long straight points, you'd be more likely to reach a constant speed there. So hopefully you had a go at that, and hopefully that's given you a little bit of an idea of what the points on the track, what those words mean. So accelerate is meaning speeding up, decelerate means slow down, and constant velocity obviously means that the velocity doesn't change. Okay, so you can use the video to do this, or you can use your own research to do it. I really don't mind whatever you prefer. So click on the video link if you'd like to watch it. But when you watch it or using your own research, we need you to find out what acceleration is, what the units are. Is it a scalar or vector quantity? You know all about those from before we finished when we taught you forces. And how do you work it out? So have a go at finding out those questions, and come back to the video when you've finished. Okay, so hopefully you did that. And we know already that velocity is speed of an object in a given direction. We taught you that in the last home learning, and it's a vector quantity. So acceleration is the change in velocity in a given time. So that means it's also a vector. Because velocity is a vector, so is acceleration. So how much does speed change, how much does velocity change, sorry, in a certain time? That's what we're looking for now. And acceleration has magnitude and direction. And a change in direction or magnitude makes the object accelerate. So if something's constantly changing direction, that counts as acceleration as well. Okay, so here's the formula, and you need to make notes on this because this is really, really important, and it's one of the ones that you need to know off by heart for GCSE. So make sure that you know this. The earlier you learn them, the easier it is. So it's acceleration is change in velocity divided by time. Really, really simple. The units are meters per second squared. That does not mean you have to square anything. You don't have to square anything in this equation. Please don't fall into that trap. It's just the unit, okay? And this yellow box explains that a little bit more for you, but you don't have to square anything when you work it out. Okay, so putting this in another way, so change in velocity, sometimes you see it as v minus u. V minus u just means change in velocity. So v is the end velocity and u is the initial or the starting velocity. So when you take those away from each other, it gives you the change in velocity, and we just divide that by time. If the answer that you get is positive, that means whatever you've worked out is speeding up and getting faster and accelerating. If the answer is negative, it's decelerating, so it's slowing down. So you might get a negative answer when you work out acceleration, and that does not mean it's wrong. Just make sure that you know that v is always the end velocity and u is the initial velocity at the start. I always remember that because it's really easy to remember that u comes before v in the alphabet, doesn't it? A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, U, V. Easy. U at the start, V at the end. That's how I remember it. Okay, so let's have a go at one together, and you can see how I've done this one already, but I'll read it again and I'll explain what I did. So in a 5-second period, so I know that time is going to be 5 seconds. Okay, the velocity of an object changed from 5, so that means that u is 5, and that to 100, So v, the final velocity, is 100. That's a 1, not like an L. Okay, what's its acceleration? So the first thing I've done is 100 minus 5 divided by 5. Simplify that to 95 divided by 5. Answer, third step, 19 meters per second squared. Underline it so that you know it's our final answer. Really, really simple calculation. You can all do that, no problem. The hardest part of these is extracting the numbers from the question, but with a little bit of practice, you'll be really, really good at that. Okay, so next example, and I'll work through this one with you. It really helps me to write down all of the letters. I kind of showed you this last week when we did speed, but it really helps me to write down all of the letters, and then I can write down what I know from the equation. So if I'll read the question and then we'll put them in. So in a 20-second period, the velocity of an object changed from 28 meters per second to 4 meters per second. What's its acceleration? So I know already that this object is slowing down because it's gone from 28 to 4. So immediately in my head, I know if I don't get a negative answer, I've done something wrong here. Okay, so just be aware of that. Right, I'm looking for acceleration, so I'm just going to put a question mark so I know that I don't need to write anything there yet. V, final velocity, is 4. U is 28. T, 20. If you can get those numbers right, you're sorted. Right, there's my equation. So I need to do V minus U. So 4 minus 28. And then I'm going to be dividing that. Oh, sorry, I meant to write 4 there. 4. Do you know what? I'm going to rub it out. There we go. Do it again. 4 minus 28 divided by 20. Okay? Right. I'm going to use a calculator because since we've finished work and since we've been locked down, my mental maths is not what it used to be. And my class would tell you that I don't think it was that great in the first place. But I'm just checking because I don't want to get it wrong and embarrass myself on here. So minus 24, definitely could have done that in my head, divided by 20. My dog's barking in the background again, I hope you can't hear him. Right, minus 24 divided by 20. Answer is minus 1.2. Now that's obviously not finished, need to do the unit, meters per second squared, and I'm going to underline that. So I know that I got a minus answer, and that's not wrong, it just means it's slowing down. So hopefully you managed to follow that one. Right, so obviously if you need any help with this, you can always ask your teachers, but on the Word document that your teacher's attached on Teams or has been printed for you, you need to have a go at either the silver or the gold questions. They're pretty similar questions, except the silver ones tells you what to do at each step of the calculation, so you shouldn't get too stuck with what to do. Just follow the steps, and you can always have a go at a few of the silver and then a few of the gold. That might help you out. Try and challenge yourself as much as you can, because remember that now that you're being considered as year 10s, whatever you do now is towards your GCSE, and we need to make sure you're exactly where you need to be when you come back next year. So let's really try and challenge ourselves. Have a go at them and make sure you show all of your work in, and use a calculator if you need to. Don't use a calculator, totally up to you, but try and mix it up and try and do the most challenging questions you possibly can. Okay, when you finish that, on the last page of the Word document, I want you to construct a revision poster as part of your assignment. So I've given you some kind of, like, you can choose either the silver or the gold option, and I've copied this slide into the Word document as well, so you don't have to pause this part of the video, it's in the Word document for you. But I just want you to summarise everything that we've been through about speed and acceleration so that you've got it all in one place and we can check that you've really understood it. As always, if you have any problems with the assignment for this week, ask your teacher. You've got all of the first week to make sure that you ask any questions. I know that you've got like certain times of the week that you have to be online, but we're online for you to ask us questions, but you can always ask us and we'll just get back to you as soon as possible. You don't have to ask us in that time. We'll just get back to you when we can. Okay. Right, so hopefully you'll be all right with that, but just make sure you ask us if you need to. Right, I've not got a TV recommendation for you this week. Instead, I've got a YouTube recommendation. As you can see, our YouTube channel has only got a measly 17 subscribers at the moment. My goal before the summer holidays is to get 100 subscribers so that I can get a custom URL for our YouTube channel. That is my dream. Please help me make my dreams come true by subscribing to our YouTube channel. This video will be on there, and I'm going to do some more do try this at home videos, so please subscribe for us. Thank you. Have a lovely fortnight. Make sure we're here if you need us. We already miss teaching, so give us a shout if you need anything. Bye.